So to get things kicked off, this is our third of 3 sessions. So I just wanted to introduce myself. I'm Tayber Yastremski from AEE Alberta chapter. I'm one of the board members. I'm going to be the host for the rest of this third segment on building energy analytics. Today's topic that we're going to be covering is energy tools for building controls, optimization, and energy savings. Our previous topics obviously were around building analytics in general. This one really honing in on the tools that interact and work with the buildings themselves. So we've got a unique opportunity today to hear from 3 industry experts. All 3 individuals are based in Canada. We really want to take that Canadian approach. So before we get started though, I want to take a moment just to acknowledge that we are hosting this virtual gathering on the traditional territories of many different First Nations, Métis or Inuit, whose footsteps have marked these lands for centuries. So please take a moment to recognize the traditional treaty land where you live today, which is an important step in reconciliation. So today, let me just share my screen with you. Okay. So today, as discussed, we're going to be starting with introductions. We're going to move into the presentation from each of the individual teams. Each group is going to be going through one of their tools. We've got 4 presenters across 3 different products today. Each presentation is about 10 minutes long. We're going to move into a panel discussion. We've got a couple sort of heavier questions that we're hoping to discuss as a group. And then we're going to move on to some Q&A at the end. So please use the Q&A box at the bottom of Zoom that allows us to sort of organize. You can vote on questions that you think are pretty key and bump them up further in the line. And then my colleagues Joad and Vasily, that are both also on the AE board, are going to be going through those questions and help sort of vet and deal with some of those. So without further ado, I would like to pass the screen off to Danielle. She's from AE Atlanta, and she just wants to give a brief introduction, and thanks for coming to the webinar. Danielle, take it away.
Hi, everybody. As Tayber said, my name is Danielle. I am the Membership Engagement Specialist with AEE in Atlanta. And I just wanted to let you know, if you're not already a member, just kind of give you a brief introduction to who we are. Our mission is to shape the future of the energy industry through networking, energy awareness, education, training, professional certification, and recognition. We do this through our mission, our vision, which is leading the global and energy community to meet the challenges of a clean and sustainable future. One of the big things with being a member of AEE is having the ability to network and get ahead. Also, we have trainings and all kinds of awards, conferences. There's a bunch of ways to get connected. So sorry. I said I recommend you going to our website, checking it out. If you have any questions about your membership or becoming a member or anything AEE related, you can reach out to me. My email is danielle@aeecenter.org. I'll put that in the chat box so you guys can have that. And good luck on your meeting today, guys.
Great. Thanks, Danielle. Perfect. So for those of you that are not currently members of AEE, just a brief rundown of what we are. So established in 1977, headquartered in Atlanta. We've got over 18,000 members, 30,000 plus certified professionals, and that number is rising, especially within Canada. That's one of the key certifications that we're using across the board. Yeah, so it's a great group to get involved in. We're always looking for additional volunteers or people to join the organization. So if you do have any interest in joining any of your local chapters, please feel free to reach out to myself or anybody else in this group, and we can direct you to whatever chapter is closest to you. Or obviously, you're more than welcome to join us in Alberta. So without further ado, we're going to jump into the actual presentations, the stuff that I'm sure you're all here to see. So today's session is going to start basically with, we've got Dan Lellen from IO Airflow. So Dan's the Chief Technology Officer at IO Airflow. He earned a B.Eng at Lakehead University, an Emis, a Master's of Science in Mechanical and Mechatronics Engineering from Waterloo University, and has been registered as a professional engineer with EGM since 2016. Dan has spent most of his professional career designing and optimizing systems for a holistic, customer-centric perspective. So he thoroughly enjoys coffee and apparently has 7 brew methods at home alone and counting. So with winter coming, I imagine we're probably closer to 8. So anyways, without further ado, I'm going to pass it off to Dan at IO Airflow.
Thanks, Tayber. Can everyone see my screen and hear me?
Yes.
Yes, nodding. That's great. Thanks. So as Tayber mentioned, my name is Dan Lowe, and I'm the Chief Technology Officer at IO Airflow. And today I'm here to talk about how you can improve building efficiency and health with accurate and relevant data. The problem that we've experienced and that many of you face, I suspect, is the lack of building data. This is data that would be typically used by building operators or by energy auditors as well. It can be data such as temperature, pressure, relative humidity, energy consumption, air quality, etc. Older buildings, they often have the least amount of data, but they're often the worst performers in terms of efficiency, greenhouse gas emissions as well. The other part of the problem with the data is the cost of that building data. So traditional audits can be cost prohibitive for many commercial buildings, especially the Class C buildings of the world, which comprise the majority of the building stock. Much of that will be around for the next 50 years and beyond. So it's important to make the data accessible and cost effective. Manual audits can often collect insufficient data to identify specific problems that may exist. Walk around with handheld sensors is a lot more challenging and produces a lot less data than an automated solution with IoT or Internet of Things type hardware. BMS and BA systems are great, but they're capital intensive and many buildings just can't afford them and won't see the return on investment. We'll just quickly go through the value of efficient and healthy buildings. You're probably well aware of a lot of these facts, but in terms of an efficient building, decreased building operating costs. So regularly commissioning a building can reduce energy costs by 13 to 16% just by optimizing the existing system, not even replacing anything. Maintaining an indoor temperature of 21 to 24 Celsius can decrease building HVAC maintenance costs by upwards of 20%. So there's the operating costs, which is the tangible, easy to track through utility bill type costs that are very accessible. But what's less accessible, I think, is the healthy buildings approach, which is making sure that the space is comfortable and that the air quality is good so that tenants can be more productive. Cognitive performance decreases as CO2 increases. It decreases as temperature ranges go outside of the comfortable range, right? So it's also important to realize that the tenants are often or almost always the most important or the most expensive part of a building, right? But that's easier to track through things like productivity. But a 2 degrees Celsius deviation from some optimal set point results in a 2% employee productivity decrease. Hard to quantify that often, but there's a lot of research out there, especially since the pandemic, on productivity and thermal comfort. Ventilation rates as well. If you can increase the ventilation rate to 24 liters per second per occupant and above, you can reduce building-related illnesses and absenteeism by over 35%. Another cost that's often overlooked because it's harder to track, right? So our solution is automation. We use non-permanent wireless sensors to collect accurate and relevant building information. The sensors are quick and easy to place, not install. You don't need any wires. They're not affixed to a wall, so low impact, and they're all multivariate. So they can collect temperature, pressure, CO2, and any other relevant sensor, any other relevant variable that you might track. They collect data over the course of 30 days and beyond. That's per one charge, but it depends on the type of sensor used, and that requires no additional effort. So in a matter of hours, you're up and running within a building. It can collect data for 30 days and then provide the analysis based on that. So the data is automated and uploaded. Floor plans, sensor data, all of that is categorized. And when the data is categorized, it means you can automate a lot of the analysis and run different machine learning algorithms to look for trends in that data as well. The results are then presented clearly and succinctly in a dashboard and through reports, both of which are customizable to suit your needs and what your company does. A couple of quick applications. So automated standard analysis, whether it's ASHRAE 55 for thermal comfort or 62.1 for ventilation, whatever it is, you can automate the analysis. Here's a quick figure showing relative humidity versus temperature each of those circles is a sensor that was placed within a specific location. And so you can get a really quick idea of how that space was performing over that period of time. We've also overlaid thermal comfort. So from 0 to 100%, the percentage references the amount of time, the amount of occupied time. So 9 a.m. till 8 p.m., 9 a.m. till 5 p.m., whatever that ends up being, the percentage of the occupied time that that sensor or that space was in that comfortable realm. So there's a lot of data that can be automated and visualized succinctly. It can also be used for exploratory analysis and building control evaluation as a tool. On the right, you'll see a floor plan of a building we tested a while back. So there are 8 zones here represented by those black shapes. The zones are defined by a single thermostat with a VAV box. And the goal of a zone is to control the temperature within that space. Well, that wasn't actually what happened here. You can see the colors don't all line up of the circles within those black sections. We used some machine learning to cluster those based on how the temperature responded over time, right? Ideally, you would have the same response over time if that zone is performing the same. In this case, it didn't. So you can use it for zone analysis and zone control evaluation, as well as energy use optimization. While we don't connect directly to any metering at this point, we can measure things like temperature, for example. Some of the older buildings that we've tested may have 1, 4, maybe thermostats within a 10, 20, 30,000 square foot floor plate, and they'll often be on the interior of the space, not the perimeter, which is a little harder to control. They'll be on the interior and they'll average it. So the system may think, thumbs up, I'm hitting the right temperature, but that's not what the occupants are experiencing, and that's not what the building is experiencing either. And so by placing these sensors within the occupied space in that non-permanent manner, we can evaluate things like optimizing temperature set point schedules as well. Ventilation is really important, more so now than in the past, I think, with virus transmission being quite so prevalent. But the actual rate of ventilation versus the calculated can often be different. If there were renovations that occurred where maybe your return duct or return vent was removed from the space or blocked off, or if your supply is next to your return, you might be calculating 4 or 5 air changes per hour based on what the fan is pushing into the space and exhausting. But if they're next to each other and the space is large, you're just short-circuiting that, right? And that's not actually what the occupants are experiencing. So by using carbon dioxide as a tracer variable and evaluating carbon dioxide buildup, by evaluating the exponential decay rates of those functions, there's a lot of literature that suggests exactly how that translates into actual ACH or air changes per hour. So those are just some examples of applications. The rest of it is the data-driven recommendation. So it's hard to make a recommendation unless you have the data, and we can automate a lot of that, whether it's behavioral or operational. Those are often the no or low cost examples. Open a window at certain times of the day if you know how a building typically responds over the course of a day to things like carbon dioxide. You could schedule the use of spaces around peak CO2 or TVOC values. But depending on pressure differentials or airflow, you may want to recommend installing or programming a variable frequency drive for the fans, for example. And having the data allows you to back up that justification and back up that retrofit, and allows you to prioritize them as well. So I mentioned earlier, but the goal of this all is to make it automated and customizable. So bottom image there, you'll see just a quick screenshot of our dashboard. The modules on the left, everything's been designed to be modules. So if you say, hey, these variables are great, but I would really like to track X, with very little time, we can bring that variable online so that when you log in, you see that within your dashboard. If you typically generate certain types of reports, we can automate the analysis so that it comes out in the format that you want, and you can incorporate that within your larger reports as well. So just to recap, automation, we think, is the key to providing accurate, relevant data to improve building efficiency and health. So we use non-permanent sensors that can be placed immediately within the occupied zone for 1 month and beyond. The analysis is automated for a cost-effective solution, and the output is customizable and automated. The focus is on healthy building outcomes for efficiency, of course, but also for health and productivity. So thanks for your time. We're exploring new hardware options to reduce cost, and we're launching our updated platform at the beginning of 2022. And we'd love to hear from you and potentially work with you. So I'll pass it back over to Tayber now.
Good. Thanks a lot, Dan. Great. Okay, well, moving into our second session. So, second panelists will be Nick Kendrick and Toby Janes, both from EcoPilot. So, Nick leads the Western Canadian Sales Division. So, he's a sustainability professional with a Master's of Science degree focused in sustainable energy development, as well as a lead GA designation. Nick has extensive experience in the control systems, renewable energy, and energy efficiency space as a whole. Toby is the Director of Technical Solutions for EcoPilot. He is their energy manager, he is an energy manager in training, backed by an extensive career with IT services management. So Toby leads the installation, management, and energy reporting for EcoPilot, especially in Canada. So without further ado, I'm going to pass it off to EcoPilot.
Awesome. Thank you very much. And thanks for the invitation to speak today. Really appreciate it. As you said, my name is Nick Kendrick. I'm EcoPilot's Western Canadian sales rep. And after I give you a quick overview about EcoPilot, Toby's going to take over and bring you into a live building. So for a very long time now, a range of materials have been used for their thermal properties, which can create a seasonal advantage, heating in the winter and cooling in the summer. Utilizing thermal mass for this purpose became the premise of academic research in Stockholm, Sweden. Where they believe that thermal dynamics could play an important role in reducing energy use and improving building performance. So EcoPilot was born based on the idea of utilizing free heat from construction material, machines, people, and solar radiation. This thermal energy is stored in the framework of the building, released over time, and harnessed by existing building assets. Traditional building automation systems aim for a constant indoor temperature based on fixed reference values or outside temperature. Typically, these systems don't account for thermodynamics, weather, or internal loads, which can have a varying effect on comfort and energy use. EcoPilot uses both static and fluid elements to optimize HVAC control based on the long-term heating and cooling needs of a building. EcoPilot uses a building's thermal mass to enable it to store energy, providing inertia against temperature fluctuations, working proactively and not reactively. So how does it work? EcoPilot interfaces and acts as a brain to work on top of a building management system to proactively control based on three main principles. The first being thermodynamics, as I said, so the thermal storage capacity of a building and to release energy slowly over time. Number two being real-time internal temperature, a critical component to understanding the thermal properties of a building, which is impacted by internal loads such as computers, lighting, people, solar radiation, as well as to measure optimal tenant comfort. And lastly, a 5-day weather forecast, including outdoor temperature, wind speed, wind direction, sunshine hours, and precipitation, so that EcoPilot can proactively prepare a building for HVAC needs in the most efficient way possible. So EcoPilot runs its algorithm every 2 minutes to optimize BMS set points in order to align with the new building balance point temperature. EcoPilot intelligently controls supply temperatures and set points to centralized systems such as boiler loops, chiller loops, AHUs, and it is enabled to enable or disable these systems as needed. And if VFDs are in place, it will also offset air and pump flows. Better alignment of these systems ensure efficient operation and balanced comfort. Systems that are proactive rather than being reactive, ensuring that there's improved indoor climate for occupants and significant energy savings. So in short, EcoPilot is recommissioning the building every 2 minutes, 24/7, 365. Next one, Toby. And based on over 1,200 installs, EcoPilot averages 25% annual energy savings with an average ROI, return on investment, of 3 years, and delivers a much more balanced and comfortable space for tenants. So beyond energy efficiency, EcoPilot improves occupant comfort, reduces carbon emissions. We provide building assessments for free, and every project is backed by an energy savings guaranteed pre-install. Clients are also given the option to pay back based on actual documented energy savings. And next one. Oh, not going. Anyway, this is about, oh, there we go. I'm going to hand it over to Toby anyway. He's going to take you into a tour of Cogswell Tower, which was our first North American commercial install a few years ago. Since then, they've expanded it to the entire campus of buildings, which includes 3 office towers connected by a larger retail mall. I just want to make a note too that this was a BOMA Best Gold and LEED certified building, and it still had energy savings on top of that. With that, I'll hand it over to Toby.
Thanks a lot, Nick. Appreciate it. Give me a thumbs up if you can hear me, Nick. Yes, excellent. And you can see the screen as well. Success. So yeah, Tobias James, Director of Technical Solutions. This is usually a 15-minute demo. I've got 4 minutes today, so it may seem a bit fast, but you can ask lots of questions later and even follow up via email in the future. So first thing I want to show is the savings. So this is the dashboard for EcoPilot. The first thing you see are these speedometer like graphics. And what we're seeing is the amount of energy that was saved, in this case, for electricity in cooling. So it's just the chiller and the pumps that supply that chilled water to the building. So we're saving 5.9 watts per meter square in this building currently. That's based on the reference, and this is called an energy signature that we use to constantly M&B the building. Next one is the temperature sensor. So we're saving energy, great, but do we have a comfort issue in the building? So next step is to check what are the temperatures throughout the building. Now, great, I logged in here today and I see that actually there are a bunch of cold sensors. Well, I looked at them and they're reading 0, which means they're actually not reading. So I sent out a quick email just before we jumped on here to let them know some of their sensors have stopped reporting. But the ones that are reporting are the important ones. And we're seeing that the comfort range in this building is somewhere between 21 and 24 degrees, similar to what Dan mentioned earlier, actually. So we can see that the median temperature in each one of these zones is well within that comfort range. And that's the key for EcoPilot. We want to make sure that everybody's able to get within 21 to 24 degrees Celsius. We know there are going to be extremities, people who want it a bit cooler, people who want it a bit warmer, and that's not the battle that EcoPilot wants to fight. So we're happy, fairly confident that throughout these zones, people are able to attain their comfort levels. So we're saving energy and people are able to be comfortable in their space. Next one, types of systems EcoPilot controls. Down the left side here, you'll see, in this case, this is a 14-story building built in the 70s, 18,000 square meters or so. And we're controlling the chiller. We're controlling a secondary chilled water loop, which is supplying window coils. We're controlling a high temperature heat loop, which is actually just the boilers, and then a low temp loop, which is a secondary loop off of that. We're also controlling I think 12 air handling units in the building, just the way that it's broken up: north, south, east, and west, upper and lower portions of the building, and then interior air handling units as well. So those are the types of systems we're controlling in this building. That's across any building you can imagine. Any centralized heating, cooling, or ventilation system is something that EcoPilot will control. The way we control those is by sending an offset. So we send a supply temperature offset to either a chiller or cooling loop, heating loops, air handling units, to prepare the building. And again, this is touching on what Nick said, prepare the building for all of those dynamic factors that are coming up, which is solar radiation, wind speed, precipitation, occupancy, outside air temperature, thermodynamic properties of the building. So the sort of how much energy can be stored in the space and how quickly will that energy dissipate out of the space. So calculating all of that, every 2 minutes, we send those offsets to prepare the building for what's about to happen, and in turn, create a more comfortable environment and save energy. In this case, I think the slide showed 25%, 24 or 25% on their heating and cooling ventilation needs in the building. So pretty good savings. So the last thing I need to show before wrapping up is what our sales and marketing person calls the aha moment. Oh, and now of course I'm unable to click. Brilliant. I was worried about this. I'm in a hotel, so I've turned my video off. Maybe this will resolve the issue. No, unbelievable. There, I'll quickly look at this building. So what it is I'll explain sort of how EcoPilot does it. We look at the pre-existing building automation system. So in this case, we'd be looking at 73 degrees, 73.69 degrees Celsius in this heating loop. So that's what the BAS before EcoPilot would be calling for that. We're analyzing all that data that we spoke about, and every 2 minutes sending that offset, which in this case is a 9.78 degree offset. Again, constantly being updated based on all of those future data points. So there is the what we do. So I should say the how we make those savings. We analyze the data and then make this adjustment to each system, and we make that every 2 minutes. So we actually action all of that analytics that we're doing. So fully out of breath, but I've made it through. So Tayber, I think I can hand it back to you.
Perfect. Thanks, Toby. That's fantastic. Great. Okay, well, moving on to the third presentation, we've got Ricardo, who is the Business Intelligence Analyst for Smart Buildings at Copper Tree Analytics. So Ricardo is an engineering technologist with over 25 years of experience in energy management. He began focusing on building energy analytics in 2007, a path that led him to the formation of Copper Tree Analytics, which is now a global leader with over 2,000 client buildings and analytics implementations on 4 different continents. Ricardo's team works with organizations seeking to reduce their carbon footprint, enhance operational efficiencies, and improve building performance through energy monitoring, fault detection, and diagnostics, as well as data analysis in one comprehensive platform. So he's a certified energy manager and holds a diploma in electronics engineering technology from the British Columbia Institute of Technology. Ricardo, take it away.
All right, thank you very much, Tayber, for that introduction, and it's a pleasure to be in this panel discussion. It's great to see these different products in the market today. It's incredible how things have progressed in the last several years. Hopefully you can see my screen, and in the next just a few minutes, I'll take to look at energy management and information systems as strategic tools for proactive energy management. Just a quick introduction about who we are. Copper Tree Analytics is the developer of Kaizen, which is a software as a service platform and a tool that is positioned for continuous improvement processes. And Kaizen continuously acquires data from buildings, monitors system performance and energy consumption, and analyzes equipment operation to detect faults and anomalies. So how do we define energy management and information systems? According to the Lawrence Berkeley National Lab, the term EMIS refers to a broad family of tools and services used to manage commercial and institutional building energy use. We have been the Copper Tree here. We have been privileged to work with LBNL as our research partner. And they do have several resources that you'll probably be interested in. Those are in attendance today. If you go to, for instance, smart-energy-analytics.org, you can probably download several of those resources that will be very helpful. And this diagram actually is one of those publications showing in the left here various data sources, and those are being collected, of course, at central repository or what we call data warehouse. And this data is then consumed by the various tools or applications as seen under EMIS capabilities. Now, EMIS providers, of course, they offer these capabilities in different ways. And Copper Tree, for instance, we have what we call 2 integrated platforms. We call one of them is Kaizen Energy, which is the energy information system. And then we also have our flagship product, which is the Kaizen FTD, or fault detection and diagnostics. Okay, so What's the difference between building automation systems and energy management and information systems? We get that a lot. And to clear up some of the confusion, let's look at the differences between these two very important platforms. First of all, from the point of view of role, BAS platforms interface with HVAC, lighting, and security systems to monitor and control space temperature, humidity, ventilation, lighting, and so on. Whereas EMIS interface with building automation systems, energy meters, IoT devices, utility and weather data to monitor its energy use. In terms of function, BAS systems provide real-time system and equipment out-of-range alarms. They are involved, of course, in the monitoring and control of equipment. And EMIS provide historical analysis and identify optimization opportunities. And in terms of data range or visibility, BAS typically have very limited portfolio building and system level visibility, whereas EMIS are typically more comprehensive because they are able to look at a variety of systems happening within a portfolio. So let's look at the data acquisition and analytics infrastructure of a typical EMIS platform. Of course, this is focused on our deployments, but it's very similar to others in the market today. If you look at the lower layer, for instance, plant, building, zone, HVAC systems, and other systems in the building are layered by a monitoring and control infrastructure, which is shown just higher up, which is typically made of building automation systems. There's metering systems, IoT devices. And the task here is to do the acquisition by integrating all these data sources. And it can be done by either a hardware device, or it could be done by cloud integrations, which is what we're seeing more and more nowadays. And then once the data is collected, it continuously flows into the servers. Then engines can go and examine these data sets to generate reports and notifications. We call them insights, and initiate action. Here's a top list of measures implemented using EMIS technologies. Energy information systems, for instance, help improve HVAC scheduling, reduce base load and off-hours energy use, reduce peak demand. On the other hand, you have fault detection and diagnostics platforms that are also improving HVAC scheduling, but also improve economizer operation more at the system level, reduce overventilation, reduces simultaneous heating and cooling, and so on. So these are this is a very short list of some of the measures that have been implemented in different facilities with these type of platforms. All right, now in the next few slides, I just want to introduce some of the ways organizations are engaging with EMIS tools. Energy management systems, or ENMS, are ways organizations set and achieve objectives and energy targets in order to improve their energy performance. Some of you have probably heard of ISO 50001 Energy Management System Standard. So that's one of the frameworks that are out there for implementing such a program. Now, while ENMS is focused on strategy and processes, EMIS provide the tools and technology to help implement those processes. So that's a key difference there in terms of what they are, even though they are similar in name. Here's a quick video sequence, not as good as that demo that we got from Tobias, but in this, we are comparing energy consumption with baseline, a monthly or daily basis analysis, and it helps identify issues early and quickly visualize improvements as well. And now another key feature is the ability to normalize energy data. For instance, kilowatt hour per square meter, kilowatt hour per occupant, or any other metric that is relevant to the organization. So that's one of the key components of our platform. By the way, MTNR, which stands for Monitoring, Targeting, and Reporting, is a focused energy management framework. And it is built on a data-driven foundation as well. Now, EMIS tools are also being used as the backbone for MMV initiatives. I think one of the speakers here also mentioned these. And this slide highlights the energy baselining functionality that is required. I'm actually in the middle of writing an article on the role of analytics in measurement and verification. And for those that want to follow the IP MVP protocol, for instance, to develop and implement an MMV plan, know that energy baselining is a core component of that. And now this diagram illustrates the monitor-based commissioning process. So from the data collection to the data warehousing to data analytics, the key here, of course, is the implementation phase, which is where engineers review results, take action as required, and then the resultant activities monitor again, and where tracked improvements are reported, measurement of savings, and then, of course, doing that on a continuous basis. This is just a summary of some of the different processes that we have seen implement EMIS tools. So they always need to be hand in hand in terms of how the implementation will go in terms of the organizational strategy and so on. So we are involved in helping organizations use EMIS more effectively. And finally, just to conclude, here's a testimonial from one of our largest clients, PCL Construction. And of course, while Kaizen delivered actionable insights, the facility team at this particular hospital needed to act and implement the recommendations. So, but once that was done, then issues were eliminated, outcomes were realized. And very similar stories we hear often as EMIS tools such as what you've seen today are deployed across many organizations. Thank you for your time, and my contact information is there. I welcome your questions and comments as well. So back to you, Tayber.
Perfect. Thanks a lot, Ricardo. Great. Well, hopefully everybody got a little bit of value of getting sort of a brief insight of each of these three different platforms and tools. And hopefully the gears are turning. You guys are thinking how you might be able to leverage that within your either consulting firm or organizations as a whole. There's a lot of great tools here, along with a lot of the other groups that we spoke with over the first two sessions. So moving on to the next portion of the webinar, we're going to be taking a look, diving into the discussion section. So I've got three questions here. We're gonna start directing the question at one individual in particular, but then hopefully that sparks a bit of discussion and communication around, what we think the real sort of response or how the impacts are going to be with each of us in the audience. So, basically, first question we have here that we discussed was, what are the biggest challenges your organization has been facing in our sector, and what do you see as some of the biggest opportunities that are coming up for us over the next coming years? And so, Dan, if you don't mind, I'm going to direct that towards you, if you can kick that off. So really, what are the biggest challenges you're seeing in your organization, and what do you see the biggest opportunities as it would relate to us as energy managers or auditors?
Yeah, thanks. So for us as a company that has wireless sensors that are placed throughout the space, collecting relevant information is easy, but tying that into energy consumption and energy reduction has been the biggest challenge for us. So being able to measure things like inferring airflow through pressure differentials has been helpful in terms of fan flow. Temperature obviously is really important in terms of set point. When do you turn a system on? Every building we've tested, we've talked to the operator and they say, oh, well, it kind of depends. Whenever people tell me they're hot or cold, and that's when we turn it on. So he's like, oh, I'd love to have some data in order to actually adjust that properly. So we have some ways of connecting to energy consumption, but that's our biggest challenge is how do we incorporate energy consumption and energy reduction mechanisms and recommendations based on the data that we're collecting. And we have methods in place, whether it's measuring current through for specific devices or fans, but overall, we don't connect to metering systems at this time. So we lose out on a lot of that. So that's our biggest challenge or hurdle. In terms of opportunities from a tech perspective, it would definitely be a multivariate analysis. So you could look at carbon dioxide and say, great, we should increase ventilation because ppm spiked to 1250 at a certain time of the day. But did temperature also increase, or did the pressure also increase, right? And by comparing all three of those and doing some computations that us humans can't readily do by looking at figures, you can get a lot more insight into how a building's performing by creating these multivariate analyses. And from a business perspective, it would be bringing data into decision making for buildings who otherwise wouldn't have access to it. So yeah, I'll stop there.
No, that's perfect. And so I'm assuming what you mean, with that, as that data comes in and we want to see actual change, the energy manager, energy auditor, I'm assuming we get trained up, or we learn how to deal with the data that IO Airflow is putting out. Right. So
yeah, absolutely.
Make decisions, recommendations, how to actually change what's happening within the building, right?
Exactly. Yeah. So we have this tool, but we're not the energy auditors. We're a software company. We provide the analytics. So working with others to figure out how to make the better recommendations. And if you see certain trends in the data in one building, can you apply those in other buildings as well? Streamlining their workflow as well. So working with them and figuring out how to use this data in the most effective way possible. Okay,
great. I guess, Nick or Toby, do you have any comments on that? Like either building off of what Dan had mentioned, or in particular to your organization, really key challenges that you guys are seeing and key opportunities coming up over the next few years?
Sure. I could talk for hours, quite literally. But, just off of, I'll sort of start with something that Dan touched on there. For us, the challenge right now, and it's not preventing us from moving forward or anything, but it's the challenge, but it's also the biggest growth potential, I think, is the availability of data. So using wireless temperature sensors, Dan has one that's temporary. He can put it in, he can get the data he needs to do some analytics and sort of give some insights. For Ricardo, usually I'm assuming there's wiring of sensors and a little more robust of a network and data set. But again, there's cost associated with that. We're putting in wireless sensors that build a mesh network, but that's not just there yet. You know what I mean? Like every couple months, they're getting better and better, but that is the struggle for us to find a reliable sensor that, the batteries are good for 10 years, or they're energy harvesting, that don't cost more than the project itself. So that's the battle there, but I think we're on the cusp. It's constantly improving. So I also think that's a big thing for opportunity there, but not just temperature sensors, adding relative humidity to that, adding CO2 to that same sensor, and still having battery life get better and better, because obviously the more things you're sensing, the less your battery life, and you don't want to be running in changing batteries every year. So there's that battle. I would say that, as far as opportunities for us in the market are coming from policies that are starting to come, policies and market pricing. So energy pricing is going up. I think everybody on this call is going to benefit from that. And I think it's going to make the world more efficient. It's hand in hand there. The price of gas is going up and up. We're getting carbon tax. It's driving everybody to pay more attention to what's going on in their building and utilize things like this. So I've talked enough. I'll leave it at that.
Oh, but that makes complete sense, right? I mean, that's where the opportunity lies, is really the fact that energy prices are going up, especially what's just happened, obviously, here at Glasgow. There's opportunities that are going to be rolled out over the next few years where these types of things are needed. You can't just go into a building and swap out LEDs anymore. You want to get deeper cuts, deeper savings. You have to get into these more advanced features and systems. So, no, totally agree. That's great. Ricardo, do you have anything to build off of that, or sort of challenges that you guys are having or opportunities that you're seeing specific to your group?
Yeah, definitely. I think Dan and Toby have addressed very real challenges in the industry today, which is on the data acquisition side, especially when you have a building stock that spans many, many years, and there has been a lot of different products that are installed over the last 23 years, don't necessarily integrate well. Some need to be refurbished or upgraded and so on. So there's certainly the challenges of the data side that of course helps us to move forward. Another area that I would say is a challenge for us is not necessarily on the technology side, although we do have the challenges there in integration, as I said, but it's more about engaging with organizations that already have a plan on how to use the tools that are there. And sometimes when there is no plan, is like us, subscribing to a software or signing up to download a piece of software that we just use for the first week and so on, and then we never use again. So those are the things that we are really trying to help out organizations with their strategy, how to use these tools, how to become data driven, how to be proactive instead of reactive. We've heard those terms, but it's really up to the organization to actually live that and not just meet compliance reporting requirements and to just say that we're monitoring energy consumption, but it's more about really the change management side of things. Again, and there's that challenge, but the possibilities there once we have engaged organizations is amazing, because they are able to leverage the tools to be very, very efficient in doing that, and that's where we see a lot of the opportunities out there today.
Nice. No, I totally agree. I mean, that's within our company, SPG, we find that our sales cycle can be so long, because when you're trying to get in with an organization that doesn't do anything yet, you are sitting there, you're educating them for 2 years before they actually put the money forward to do the projects, implement the tools, make those changes, and it's crazy. So yeah.
And then once the tool's there, to use it.
Yeah.
In the case of Copper Tree, you've got so much information. You're getting all these insights. Dan as well at Airflow, and do something with it. We just partnered with Empowered, who do the peak prediction in the Ontario market for avoiding those 5 days of peak, to bring their energy costs drastically down. They're selling their product and letting people know when they need to do things, and they're telling me specific things that they could do to save hundreds of thousands of dollars a year per building in some cases. They weren't doing them. So they were coming to the end of their year, they paid for the service, they got all the information they need, but they weren't taking any action to avoid it. So, we've worked with them. We're going to start automating that process to make it a little bit easier for them. But the reality is you still need to pay attention once you have these products in front of you.
Yeah. Which is great. There's been some good sessions, a lot of the training sessions that our teams offered with AEE International this year and previously. We've been really focusing a lot of effort on training the energy managers to train the organizations to look for this stuff and to make decisions and really show that key stuff. So I definitely recommend anybody in the audience that is looking at how if you have that same challenge in your organization, there are some pretty good sessions that we've given over the last about a year and a half now, really focused on how do you get those people in the organizations to do something, so we don't miss these wasted opportunities where there's literally pressing a couple buttons or going into a system for a few minutes, you could save a couple $100,000, and it just they don't have time for it to do it. So
yeah.
Any other comments on this particular topic while we're on?
The value is really on bringing in the expertise that we see in buildings today and at different levels of the organization with the tools that are there to help them do that work. So it is not just one or the other; it's both coming together. So that's there's been a catalyst for that transformation to happen, and many times we end up talking more about the process than about the technology. And but that both of them are important. We need to talk about both, but it is more about empowering people. And the automation side, I think, as with the EcoPilot product, automates some of these processes, so you don't have to go and do manual adjustments of set points. But then there's also other things that need to be looked at. There's these filters are not going to be changed by themselves, and you have all this equipment that needs to be maintained. and we need to measure performance so that we are doing more proactive maintenance, preventative maintenance than reactive. So
AI can't
there's a lot of
change your
that.
filters yet. They can't change those air filters or make sure that the heating valves aren't passing and so on.
Exactly.
But yeah, that's right.
It's definitely a great time to be in our sector. I mean, what it used to be 10 years ago, 15 years ago, it was, yeah, all these tools weren't available. So it's definitely fun, which is perfect. This leads us into the next question. And so maybe I'll direct this one back at you, Toby. So very specifically, how is your product or solution transforming the job of an energy manager or an engineer specifically?
Exactly. And we kind of touched on it. This is perfect. Well done. Good lead in. But the idea is that we're doing some of those repetitive things. So we're actioning something to make sure that it's more comfortable in the spaces and they don't have peaks and valleys and have cold and hot calls that they need to respond to, because that's always the case. If you're the energy engineer and you're trying to make sure that you're saving as much energy as possible, you're doing all the right things, but then somebody calls you and says, oh, well, this thing's not working, it's too cold in the space or what have you. Okay, get rid of all of that. Let AI handle that, all of those repetitive tasks and preventative, call it preventative maintenance, but preventative programming or actioning in the building. So that you can then go and do those things that we just talked about. Okay, well, we've got 3 heating valves that are passing in the building. We've seen that through the fault detection of either airflow or copper tree. They've told us about that. Now let's go work on getting that project together. So I'm the CEM. Let's go do the financing, actually spend that effort, all my effort on actually getting something done that can't be done by software. I mean, it's hand in hand. They're both required. I think using all 3 of the tools on here today for an energy engineer, it just puts more data in front of them as well. It allows them to know more about their building without having to put, data loggers and some of the things that we've had to do over the past 10 years, as you mentioned, Tayber. And we've just got that much more data and more to think about, but it allows us to do more and more with less, I suppose. So.
No, that's great. And sorry, just to pull you in, Dan. So for you and your organization, what do you feel like your tool is doing? How is it changing the job of an energy engineer as well? Obviously, there's the data component, making more data available, but do you see any other sort of aspects that are changing with tools like this or like IO Airflow?
Yeah, I think so. Relevant data, cheap data allows people to, or empowers them to act on projects that were previously unattainable, obviously, or often due to cost barriers, but also the ability to act quickly. So we're living up in Manitoba, and schools, because of COVID, have said, hey, just max out your ventilation, bring in more fresh air, which is a solution, kind of, but it's not driven based on data, right? They're just saying, well, if you don't know, just max it out. So if an energy auditor were to go in and evaluate that space, that might take time and that might be more cost prohibitive for schools. Whereas we deployed our sensors in a school and they ran it for a week at auto and a week at maximum. And we showed that even at auto, they were able to keep their PPM below 800 in classrooms. They were able to show that their ventilation was effective. If they didn't have that data, they would have kept it maxed out. And the reason why they called us in is because one of their 4 air handlers failed because it was whatever, -20 for a couple of days. And they were bringing in almost 100% outdoor air and trying to condition that, right? So able to act quickly, right? You can act quickly and then you can say, well, hey, maybe the EcoPilot or maybe the copper tree solution or a combination is right for this building in the future, right? So it's almost a starting point. You have access to data quickly. You can act on that. Now, what do we do with it, right? So that's a couple examples that we've seen just recently that are quite relevant.
Great.
You're definitely in a, oh, sorry, Tayber.
Please.
You're definitely in an area where when you have buildings that don't have data availability, then they don't know where to start. So it's by having some insight into what's happening. Just provides the ability for them to inquire more. And we do deal with, we are focused on buildings that have data already somewhat, and we want to integrate that data. But for buildings that don't have anything like that, it's hard to help them, because when we don't put the sensors on, we are not an installer of sensors. We don't deploy those sensors. We just deal with the data once it's there. But definitely there are the opportunities for having that information, at least even if it's temporary, but give them that insight, right?
Perfect. And Ricardo, for Copper Tree, do you see how is Copper Tree affecting the way an energy manager does their job?
Yeah, the visibility of the information is one area that that helps them move forward quickly. I don't know how much, what's the percentage of time that data scientists or energy auditors spend collecting the data and cleaning it up. There's a lot of time that goes into that. So that's, as I think it was Toby that was mentioning, repetitive tasks, right? Because once you have the data, once you run it through models, and then you have to do it again, because now you have 1 month more data that you want to run it with, and so you have to do that whole process again. So there's that area of utilities that can be helping this process. The other area that we see benefiting energy management specialists is in the area of standardization. So once we learn something, and this happens to everybody, I think, you learn a new method and you learn a new way of doing things, and you want to apply it across your other projects as well, and sometimes even go back, right, and do the same on other projects that you've done. When you have a platform, you are able to standardize. Okay, this is the rule I'm going to use. This is the model I'm going to use for this particular project. And even if we have different projects, different building types, and so on, we can basically standardize the main process, the concept of how we want to measure savings or create the baseline. And if we can do that, then we can have more repetitive implementations. That again, it also helps with time, because we're spending a lot of time trying to do all these and to generate these great outcomes. And tools like these will help in that regard, because you don't have to go through this process again and again.
Right, just essentially it's that efficiency game, right? Like efficiency in the process, even, to get back to it. Yeah.
Correct. Yes.
No, that's perfect. So I see we're coming up at 1 o'clock now. I see 3 questions in the Q&A. We do have one more panel question. So given the fact we still have 15 minutes, I'm going to ask the last panel question. We'll try to keep it around 4 or 5 minutes, so relatively brief responses, but this is, to me, I think, one of the most important questions. And then we'll, if you guys in the audience, any of the participants, please, if you got questions, put them in the Q&A. Joad's just going through them right now. So if you have any questions for these folks, we'll get them in there, and then we can get those ordered and jump in those in a few minutes. So the last question I have, and I guess technically, Ricardo, it's your turn to start first. So as an energy auditor, energy manager, obviously we like the technology, we like the opportunities, we like everything that's being presented here, but we now have to go and sell that internally. So you guys can sell to them, energy manager then has to go and sell internally. So what advice do you have in order to, advice for an energy auditor or an energy manager to help sell your tool internally? What are the key tips and tricks that you got for them?
Yeah, that's a great question. I think as we engage with organizations, like very good salespeople, we need to understand where they are at. We need to be asking questions about the plans, their strategy, on using tools like energy management and information systems. So understand where they are at, so that we can provide a solution that matches that. So is some of the strategies that I can think of is listing some of the requirements that they're looking for. Maybe they are focused or concerned about GHG compliance reporting, or maybe they're having a project that they need to measure savings. So what is it that is hot under their list of items that need to be taken care of, and basically offer or present a solution from that perspective instead of just saying, well, we're selling a tool. Just look at the outcomes. So it's more outcome based, I guess, from that point of view, right? There are other strategies, like, for instance, partnering with other service providers, because we're not necessarily going to be at the building doing all the fixes. So if you could partner with a company that is doing that can achieve that, then that's it's a more of a turnkey solution, right? Not just one solution.
Nope, that's perfect. Great advice. Toby, what are you next? Same question.
Yeah. Well, I've got a fun one. This is a good one for me, because we've been in North America with EcoPilot for about 4 years, selling properly for 3 years. The first year was more of a demo, run it in a building, so we had something to talk about. It's been around for 12 or 13 in Europe, but it seems when you bring it to North America, that didn't count. So we had to put some effort in there ahead of time. So, but 3 years, so we quickly realized that let's make this easy for energy engineers. Let's make this super easy, or facilities managers, whoever we're talking to, but applicable here is energy engineers. Guarantee the savings. Stand behind whatever product it is for us. In our case, EcoPilot. We're selling something that we believe in. We've tested it. We've got over 1,400 installs. We can guarantee the savings. Here's the project. We'll calculate the net present value for you. We'll do your ROI, your simple payback. We'll present that to you as an energy engineer. You'll have it in front of you. Very simple to understand. And coming from an energy engineer sort of world, it's all going to make a lot of sense. I think selling the product to the energy engineer is the easy part. Getting it past that is the hard part that we've seen. So we made it easy. No capital outlay potentially, if that's the way they want to go. And it's guaranteed savings. So we make it really easy to sell to the financial department of your companies. So for us, we've hit those walls. We've been with energy managers for years, hitting those same walls. So we've just changed the way we look at it. We'll guarantee the savings, and we'll make it really easy for everyone. So that's my trick, workaround.
Yeah, that definitely makes it easier. Perfect. Dan?
Yeah, thanks, Toby, for setting the bar so high. Hard to follow up. Guaranteed savings and no capital. But anyways, I'll try. So we would highlight the low cost and the simplicity. You can be online and up and running in a matter of hours. There's the customization. There are all those elements that pretty much every platform has nowadays, but it's a reliable tool in your tool belt, and it's a first step to answering the bigger problems of a building. If you set out to test a certain hypothesis within a building, maybe you're suggesting that the dampers require balancing or some such thing. You're not just collecting data on that, you're collecting data on the ventilation, on the temperature, on the comfort, CO2, TVOCs, whatever it is, so you can realize more potential problems without any additional cost. So you get a pretty comprehensive look at how the building is performing and what the occupants are experiencing, regardless of what problem you set out to solve. So highlighting the quick and easy part of it, and that it's a tool in your tool belt, and you can't make a good decision without good data.
Very, very true. Yeah, very true. Perfect. Well, thanks a lot, everyone. Appreciate that. Hopefully, participants, you guys got a lot of value out of that. I know that's these are always good, interesting discussions. So I guess now let's move on to the Q&A portion of it. I'm going to pass it off to Joad. You've gone through those questions. Do you mind just directing them at where they belong and taking it away?
Thank you, Tayber. Yes, we do have a few questions here in the Q&A. You can add a few more for the participants that are still on the call with us. So first question we'll start with the one from Jorge about the average life of the project that you've been installing for your respective system. So I believe that all participants here could answer that question. Maybe let's target that first question. To Dan, you mentioned you had the temporary sensors and you had also permanent installation. Maybe you can comment on that.
Yeah, so we use a non-permanent installation is the goal. So it's a tool. It's similar to a data logger, whether it's an onset hobo type sensor or equivalent. It's a non-permanent installation with more detailed analytics and customizable reports. So there isn't necessarily an average useful life of a project, as it's normally 1 week, 2 week, 3 week, a month or beyond. But in terms of the average life of the sensors, we're getting over 2 years of accurate results depending on the calibration frequency. And so if you were to lease this hardware and the hardware is no cost, it's more of a software and report type service, then it's 2 years would be the hardware. But it depends on the use case, right? It's a tool in your tool belt, as I mentioned in the previous answer. So hard to say. I think it may be more geared towards the permanent installations of EcoPilot and CopperTree.
Thank you, Dan. We'll direct that question maybe to Ricardo at this point.
Yeah, when we connect, of course, to buildings, we're looking for long-term solutions. So it is, if there's hardware involved, of course, we know that, what's the, I don't know what the average life of a piece of hardware it is, but there's continual upgrades that are automatic as well for the hardware. So it is, we're looking for a long-term approach to the solutions that we're deploying. I guess to the life of the building, so that it is integrated with the whole management of it from a facilities perspective.
Thank you, Ricardo. And EcoPilot may be able to answer that question as well.
Sure. For us, we tie it to the life of a building automation system. The reason we do that, we average that out to be around 10 years. Because a controller, a BAS controller is going to have to be replaced or potentially completely overhauled depending on where it is in its life cycle. But we say about 10 years because of the BAS having to be replaced, and we integrate directly with the BAS. So if it's pulled out and a new controller is put in, we'll have to do some reprogramming and reintegrating with that. So we call that the actual life of EcoPilot. Reality is the physical device that's EcoPilot on site that acts as a gateway to the cloud. It's an industrial computer with no moving parts. We haven't had any die yet. So the physical life of it, isn't measured, but the life of the project, you could say, is 10 years, but it's continuous control of your building. So even though at 10 years we do a recommissioning, if you will, it still continues in the building forever. So
it becomes a subscription service that whoever needs the building needs to know the operational features of the building, which is they are tied together. Thank you for that answer, Tobias. Our next question is about the cooling load and how do you measure the cooling load using wireless sensors? Maybe that question is specifically for EcoPilot, but any of the speakers could answer it.
Sure. Cooling load, we'll look at, so the thing is someone will go into a building and they'll say, this is our cooling load or our cooling need in the building. And we'll say, okay, we'll see. That's what it is when you're reacting to the outside air temperature. But let's see what it is when you're looking at the outside air temperature, using the building as a battery, the ability to charge that building in the evening and utilize that over the day to keep the building cool and not have to bring the chiller on at all in some cases, or not have to run it at 6 degrees Celsius, run it at 12 degrees Celsius potentially. So when you're taking all that data that we talked about to control that system, your need for cooling has been changed drastically. So once we're done, then we can do some analysis. And what we do is we do quarterly analysis where we'll point out which parts of your building are actually creating the demand. So if we have to provide, the chiller has to come on because of this one specific zone constantly, well, what's the fix in that zone? What's the problem? Why is that zone the one? Do we just need some solar shading on the windows, and then the entire building doesn't need the chiller on for several days of the year and doesn't need 6-degree water, it only needs 8-degree water, these types of things. So we do that quarterly. We analyze to tell you sort of, if you want to get more out of your building, here's the issue, here's your problem, here's why your cooling demand is so high. It's only because these 4 offices, potentially. Part answer. I'll let the
Thank you, Tobias. Any of the other speakers would like to comment on that, Ricardo or Dan? Or we could just move on. Sounds good. I've got a question here that is not listed. I believe that the where do you see the Emis system projects in 10 years was partially addressed in or challenges and opportunities. I would like to take the opportunity to add another question to the list that we have. So could you comment on a situation where you provided, or the system that you used provided information to occupants, and you either had a response that you could measure, or you provided actionable information to the energy managers that somehow was able to bring value to that manager? That was mentioned, I believe, in Ricardo's presentation, but would probably apply to all the systems that were presented today. Maybe I can start with Ricardo.
Yeah, sure. I can start with that, and I'm sure the others will have some of their perspectives as well. When it comes to, I guess, customer satisfaction or occupant satisfaction, there's, especially in the last couple of years, right, we've seen a lot of these focus on occupancy. I think it started with dashboards in the several years ago, where we wanted to keep users involved or informed, at least in terms of how their spaces are being controlled. So there was the era of the public dashboards, where we would show people that are occupying the buildings, how their buildings are performing, is it comfortable, is not, or is there, we meeting energy targets, more of the higher levels, so that you can engage people to be part of that process of reducing energy and so on. And so on the reporting side, dashboards and the ability for facility teams to quickly react to issues that are happening in the space, complaint calls that they are able to hopefully even predict areas that are going to be complaint areas because of how temperatures are being maintained. And I've seen in these presentations today some of that, where you see how areas are being controlled in terms of comfort, with perhaps key performance indicators and so on. So there is that engagement of having the information at the disposal of the facility team to react to those issues. Now, in the last few years, we've seen a lot of emphasis in occupancy modeling and occupancy monitoring to essentially not just be trying to focus on energy alone, but also on how the building is actually performing from that perspective. So the reports areas that analytics and other platforms can help certainly would be part of that.
Perfect. Thanks, guys. I apologize. We're at 12:16 right now, so we're just 1 minute over. Anything really pressing needs to be wrapped up? Fantastic. Okay. Well, thank you very much, everybody. Definitely appreciate, we've got a lot of insight, a lot of opportunity to see what was, what you guys had to offer. And obviously this discussion at the end helped quite a bit as well. So for everybody in the audience, if you are not already following us or part of our newsletter, please have a look at some of these links attached here. We've got our newsletter, LinkedIn page, and our YouTube channel as well. This particular presentation, along with many of the previous ones, will be posted on there. And then if you have any questions or any interest in volunteering with AEE, obviously we're wrapping up the year now and we're going in through a whole new voting cycle, looking for some new folks to join the board. So If you'd like to get involved, please reach out at the info@aeealberta.org. Send us an email, let us know what you'd be interested in volunteering in, and we'll see where we can fit you in. Perfect. Thanks again for your time, everybody. Dan, Tobias,